Hello and welcome. My name is Cameron Stewart and I am the Senior Technical Marketing Manager here at SolarEdge. And I'm happy to talk to you about NEM 3. So I cover all of our residential storage products, our online design tools, as well as our smart energy management devices. And Net Metering 3.0 in California is going to need all three of those things. So I've been doing a lot of research on production analysis, what the offset is, how to design with systems like this, and batteries are going to be critical in success for Net Metering 3. So I like to call it the net billing tariff. I'm going to run you through on how to do a design in NEM 3 in the SolarEdge Design tool, and then what the benefit of adding a battery is going to be. So if you've never used the SolarEdge Design tool, go ahead and click the Login button, drop down to Designer, and use your monitoring portal credentials to log into Designer. If you have never created SolarEdge login credentials, just follow the prompts and create new login credentials, a new account, just like you've done for any other online tool ever. And once you're in, you're going to get to your projects list. And of course, because I have a lot of projects that I do a lot of designs on, you're going to see a whole bunch of projects in my project list. So I'm going to click the plus button or hover over the plus button and then click residential, and we're going to start a new project. I always start with projects using my name and then today's date, just because it's easy for me to keep track of the unique name. And I generally don't run more than 5 projects in a day. And I'm going to pick an address in Southern California, specifically in Anaheim. As you can see, we're powered by Google. And so as I am writing this out, it's making recommendations. So I'm going to click on the recommendation, and it's going to drop me to this beautiful home in Anaheim. As you may know, if you have used the SolarEdge Design tool, we used to put in the consumption parameters on the project detail tab. However, we no longer do that. There's no longer a consumption tile. We have a dedicated consumption tab. So I'm going to create this site and I'm going to look at consumption. For consumption, I'm going to select the utility. The utility in this case is Pacific Gas and Electric. So I'm going to just start typing and I get to Pacific Gas and Electric. I'm going to type in the utility rate. The most common utility rates that I pick are on the top here. And so you can see, I'm going to just pick NEM 3. And then of course, I'm going to set my export rate. Now here's what's interesting. So NEM 3 is not only a very interesting time of use rate where you're on peak time in summer months between the hours of 4 p.m. and 10 p.m. are 53 cents per kilowatt hour to buy energy. In the winter time, you can see that you're at a lower peak rate around 27 cents per kilowatt hour, January to May, and then October to December. And then this whole period in the morning, you can see is usually pretty low peak rate, 26, 27 cents, 30 cents per kilowatt hour. So really the hard hitter is this summertime 4 to 10, which is again 53 cents per kilowatt hour. I'm going to close this and I'm going to show you what the most interesting part is. It's the export rate. So we can see here we select an export rate, and the export rate is for any investor-owned utility in the state of California is got a unique rate of value of energy that is exported to the grid hour over hour for every weekday of the year and weekend of the year. So we can see that in January, or let's look at this dark red. So when you see dark red, that means your export rate is almost nothing. We can see on March and April and May, we have a lot of great usable solar energy. A lot of PV systems are exporting during this time, and there's not a lot of demand on the grid for energy. So PG&E is not going to give you any money for this. In this example, at 1300 hours, so 1 o'clock in the afternoon in May, if you're exporting energy to the grid, you're only getting 0.9 cents per kilowatt hour, 0.92 cents per kilowatt hour. Not even a penny for that energy that you're selling back to the grid. So there's no incentive to sell energy to the grid during this time. However, If we look in the summer months and we look at September, the power hours, we see that from 6 o'clock to 8 o'clock, you have a really high sellback rate. $2.65 per kilowatt hour and $2.99 per kilowatt hour. And on the weekend, it's a little bit lower, but not too bad. So in the summertime, you're really incentivized to sell energy to the grid at this time. However, you should be thinking to yourself, well, at 6 o'clock and 7 o'clock at night, there's not a lot of solar energy being produced in September. I mean, yeah, there's sunlight, but not a lot. And so batteries are going to be critical to investments and payback rates in the net billing tariff environment. So I'm going to cancel that. And of course, to understand how the homeowner uses energy and how we sell energy, we have to put in our consumption data. So this house, let's say, uses 12,000 kilowatt hours annually, and we can upload a consumption profile. We can say, oh yeah, they're retirees or they're working from home, so they have a lot of daytime focused consumption. I'm going to choose that. If you have green button data, you can upload it. So that's every hour of the day for a full year, the 8760 data. You can upload that data here. So if you have PG&E, it's green button, you just click the green button, download the information for the homeowner, and you can upload their exact consumption profile to our tool. The next step is site modeling. Now, this is where a lot of people get confused or upset or have difficulties. We're always improving. And so one of our new tools is the outline roof feature. So I'm just going to click this button. It says roof outline detection. And I'm going to left click and drag and detect all of the outer edges of the roof. So I'm just going to make sure all the outer edges of the roof are highlighted. And the SolarEdge tool is going to decide what the roof looks like. Looks pretty good to me. I'm going to move this line up just a little bit. And maybe this line up just a little bit. Okay. And maybe this line down just a touch. All right. And yeah, maybe this line in just a little bit. Okay. I think in general, that looks really good. All right. Now I'm going to use the inner edge tool. Now the inner edge tool works so long as all of the outside edges of the roof are parallel with the ground. So there's no rakes in the roof system. So all of the outside edges of the roof are parallel with the ground. So I'm just going to click inside the polygon that was created from the roof outline detection, and the tool just automatically draws all of the inner edges. And it looks pretty good. I'm just going to run with this design. It looks like, I could probably move this up just a touch. Okay. And I'm going to run with this design. Okay, that's pretty straightforward. I'm going to add some obstacles. So let's add this obstacle right here, this chimney, and this vent. I'm going to add this vent. It looks like there's a giant ham radio, maybe antenna right there. I can't possibly think that would be a TV antenna these days. It could be. And I'm just drawing all the obstacles. Like, I don't need to draw this obstacle, but I can see it's going to cast a little bit of shade on that roof surface right there. Okay, that's all the obstacles. If I wanted to add some trees, I could add some trees. Like, we could add this tree right here and see if there's it looks like more like a bush and not a tree, but I'm going to add that bush. And maybe if we wanted to add this one here and this one right here, and this looks like a pretty tall tree. So we could add a really tall tree right there. Okay. That looks great. Now let's get to 3D modeling so we can adjust the height of our shading elements. So you can see that the roof already has a 3D shape to it. And the reason it does that is because we use the inner edge tool for it. So we didn't have to adjust our roof slope. I'm just going to adjust the height of this chimney and give it a very exaggerated shadow, just so we can see what the effects or impact of that shadow is going to be. And I'm going to drag that one up and this one up, and the rest of them I'm going to leave pretty much flat, just like they are. I'm going to drag this one up too, just a little bit. Okay. Maybe a little bit more on this one. Okay. And so now let's get to PV module placement. Now to set a solar panel, we can just click on a roof facet and add a PV module. So the first thing I like to do is set the setback requirements, which is basically going to create a keep out zone for all of my solar panels. And you can create specific setback profiles for different AHJs. For example, maybe this AHJ requires that you're 36 inches from the eave, and we can say the eave is any outside edge that is parallel with the ground. And maybe a different AHJ says, oh no, you only have to be 18 inches away from that. Or you can go all the way down to the bottom of the eave. And I'm going to select hips and valleys, 18 inches there. And the reason I like to select 18 inches for hips and valleys is because that gives us a 36-inch walking lane. It's 18 inches on either side, right? And then ridges, we can say 18 inches. And if you don't know what a ridge is, that's the ridge, the top, the highest point on the roof. And then the rake. Now the rake is what we don't have on this particular roof. And you can hover over the question mark and see what a rake looks like. But that is when you have a outside edge that is not parallel with the ground. We don't have any rakes in this application, so I'm going to undo that and then just click apply. Okay, so now we have all of our setbacks identified, our keep out zones, and I'm going to go ahead and drop some solar panels. So let's start with this eastmost facing array, and I'm going to click the add PV module button. I'm going to use a landscape orientation just because it's a comp shingle roof and we're probably going to install a railless racking system. So I'm going to left click and drag and add some solar panels to this. And all right, that looks pretty good. Now, if I wanted to see what the impact of the shade is, we saw a big shadow right here, right? I can click the irradiance button and we can see what the impact of the shade is. So I'm going to left click this module and delete so we can see where the affected shade area is. And we can see right here, in this specific area where the shadow is most prominent from our satellite image, this spot is going to produce around 70% of its annual expectation. 70%. And we see that anywhere else on this eastward facing facet is around 80%. So we're losing about 10% of our annual production. And that's specifically when the sun is setting, right? I'm going to put that module back into position because that is a good reason to have a solar panel right there. 70% is not a ton of loss. And I'm going to situate my array just a little bit more to see if I can get one more solar panel over here. I cannot, does not fit. I'm going to see if I can get one more solar panel up at the top. Oh, I can get one more right there. And it looks like I might have shading issues right here because look at this. This is only 30% production. So this solar panel actually may not make a lot of sense because it's on the north side of that chimney. So of course that one doesn't make a lot of sense. All right, so let's go with this array here. Let's go to this roof facet and I'm going to add some solar panels right here. And of course I'm going to do the same thing. I'm going to situate some modules in between these vents here and the setback lines. Okay, and I'm going to add another group of modules just so I can get a custom location for them so I can really dial in where these solar panels are going to be placed. I'm going to move this up just so I can have a little more flexibility. Yeah. And of course that would drive this location to move up quite a bit. Okay. Cool. And then we're going to add probably one more solar panel right here at the top. Looks great. And of course, if I were installing this, I would try to line up these modules so that they're on the same plane. Okay. Great. Now we're going to go down here. Here's another roof facet, and it looks like I may only get like one, maybe two solar panels. I can get two solar panels on this array. I might be able to get one more. Let's see. Let's see if we can get one more. Ooh, I can get three on this area right here. Let's go over here. Let's see what we can get over here. One, two, probably another three. All right. And then let's go over here, see what we can get on this side. Looks like 8. Fantastic. I'm sure if I staggered this a little bit, I could probably get 1 or 2 more right here. So let's move this up and see if I can get 1 or 2 more. It's so close. Yeah, I can definitely get 1 more. Don't think I can get 2 more. Well, let's try to do the stagger. So I'm going to stagger this. Cool. Oh, it's so close. I don't know if there's any way I can get. All right, we got 3 modules here. All right, and then we're gonna do our offset modules like this. So we were able to squeeze out 2 additional modules. And what I'm trying to do is just make sure that everything's aligned appropriately. So I'm just dragging up and we can see that those modules are aligned. All right. So we have our offset stagger and we were able to add 2 additional modules on this roof surface. And I'm just going to move this array over just a touch. Fantastic. If we go back to satellite view, turn off our irradiance, we can get a good visual representation of what this system will look like. We can see down here on the counter, on these 3 dials, on the furthest right dial, we have our annual estimated energy production. So that's 20 megawatt hours versus our annual consumption, 12 megawatt hours of annual consumption. So this system is way oversized. I want to look at what a PV only system looks like. So we're going to generate electrical design and we can see what our DC to AC ratio is. So our target is 125% DC to AC ratio and our actual is 125. And of course, if I wanted to slide this slider up, I can get smaller inverter recommendations. So if I go all the way up to 166%, I can drop this down to a SE7600. I'm going to go back down to the 10K. So we'll say 142 is fine, 10 kilowatt inverter. And instead of using the standard home wave inverter, I'm going to use the home hub inverter. And the home hub is battery capable, but we're not going to install batteries yet. And for the power optimizer, I'm going to select the S500B. And now it's time for stringing. So I'm going to generate. And you could click the auto string button and the system will find the most ideal strings for you. But I like to do it a little bit by myself sometimes. So I'm going to just string this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks good. I'm going to put a string right here. We're going to go this way. Cool. And then jump over to this roof facet. All right. Looks good. And then one last string. Looks like right here. 7, 8, 9, 10. All right. We have 3 strings, 2 of 10 and 1 of 9. Everything is strung. Financial analysis tab. We're going to set a base price for the system to be installed. So if we were installing a PV only system, I think in California today, these days, it's going for about a $4.50 a watt. So we're set our base price at $4.50 a watt. We set the cost of all of this stuff in the bill of materials as 0. And as we add a battery, I'll show you why we're going to keep this stuff as 0. And then when we add a battery, we can add a price on the battery just so we can see what the increased cost of the battery is. So $4.50 a watt. Our incentives, we can see the federal tax incentive. Right now it's listed as 26%, but we got renewed. So let's see if we have the ITC 2023. There we go. System owner will receive 30% of the system. That's exactly what the new incentive is. Okay. We can say, oh, we're also going to apply for SGIP. And so what if I type SGIP? There we go. We can put in SGIP. Oh, but they're not getting a battery. So we're not going to put SGIP on this incentive. Okay. And then the financial parameters, system lifetime expectation is 20 years. Of course, we can extend the warranty to 25 years. The electricity price increase, I typically hear 3 to 5% is what we should do. So I just picked in the middle is about 4%. And that's the rate at which we think the cost of electricity will increase. And so we definitely want to account for that because that's going to affect the lifetime of the system. Now, with all this information in, we have system cost, we have the financial parameters, and we have the consumption, the offset and production analysis. So we're going to go to summary and reports, and we're going to look at what this system is going to produce versus what the home is going to consume and what the value of that energy is. So again, this system has no batteries, and it is way oversized for what the home consumes. So our total estimated production is 19 megawatt hours, and our total consumption is 12 megawatt hours. That is way oversized. PG&E's new interconnection agreements don't allow more than 150% offset. So it wouldn't even be allowed to be interconnected. And you can see that this system during the months of February, March, April, May, June, July, August, September, October, November, you're going to produce more energy than your home consumes. Looks like December and January are the only 2 months that you're going to pay for energy. And in a NEM 2 world, that might have been great. And as we scroll down, I'm going to get rid of some of these things. As we scroll down, we can see the net lifetime bill savings is $41,000. That's your bill savings. I want to make sure that we have the correct rate. Yep. Okay, so the estimated net lifetime bill savings is $41,598. So that's not a bad deal. Our estimated payoff is 14 and a half years. I don't know how many people expect to be in their house for 14 and a half years, but that is a really long-term investment. So let's see what happens when we add a battery to this system, because right now it is way oversized and we're getting no money for our export. So I'm going to duplicate this result. I'm going to duplicate. And I'm going to rename the first design. I'm going to rename it as just Max Fit PV only. PV only Max Fit. Okay. This new design, I'm going to rename it as Max Fit ESS Max Fit, just so we can compare what the battery does. Okay, so everything's the same. These two systems are exactly the same. Let's just add a battery. All right, so we're going to go to electrical design. We're going to select our inverter. We're going to click the edit button, and we're going to say I want to add 2 SolarEdge home batteries. 1, 2. Click done. All right, now we have 2 batteries attached to the inverter. We can go to the financial tab and say, hey, there's 2 batteries here and we have to adjust our pricing because those batteries cost money. I just put in just a random number, $8,000. So that's what I'm going to put in. And we can see that the total system cost went up to $74,000. Okay, so we didn't change anything else. All we did was add 2 batteries and a price associated with those batteries. It also does impact our incentives. We can also add SGIP. So let's add our SGIP. And we could also add CARE, the CARE incentive. All right, that's 8 cents per kilowatt hour for the first 9 years. So let's add those 2 incentives. 15 cents per kilowatt hour is correct. Okay. So we're going to add those 2 incentives. And now let's look at the summary reports. All right, summary and reports. Let's go down to the bottom here and look at this. We over doubled our bill savings, $93,000 in bill savings. And our payback period is 7.5 years. So we doubled our incentive. We reduced our payback period by half. I mean, just because we can take that excess solar energy and put it in a battery. So we're self-consuming from batteries about 50% of our energy. $22,000 of this 93 came from SolarEdge's smart battery algorithm, because what we're doing is we're modeling the consumption, how the home uses its energy, versus the production estimate versus the weather data, how much we expect the battery or the system to charge. And we're then taking that information and making decisions about when and how to export the battery. So if there's no incentive to backfeed, then we will charge the battery. If there is incentive to backfeed, then we'll export to the grid. If there's just incentive, if the backfeed export to the grid is less than offsetting your consumption, then we're just going to maximize self-consume and offset your consumption and keeping that energy stored in the battery for as long as possible. And then when it does make sense to export, we will export. That is incredible. All right, so now we know that this system is way oversized. So the system cost is still too high. Let's take a look at what that system cost was. System cost was, I think, to the tune of 74 grand. All right, 75,000 bucks. System is oversized, so let's take some solar panels off the wall, off the roof. So we're going to duplicate this. And we'll say ESS max fit. Instead of max fit, we'll call it 100% offset. ESS 100%. So this is going to be an annual production of roughly around 12 megawatt hours annually. All right. So we have our new system. Let's go to the PV module placement. And now all we're going to do is we're going to remove some solar panels. So I know the cost of installing a single orphan solar panel is high. So I'm going to probably target this one first, so we can get rid of that guy. And I'm going to look at this east-facing array and think to myself, east-facing arrays don't generate a ton of money because the value of the kilowatt hour in the morning is so much less than the value of the kilowatt hour in the evening. So I'm going to delete this array. And as you can see here, I'm going to delete this array and see what the impact on my production is. So I still have almost 13 megawatt hours annual production versus 12 expected consumption. Okay, I think that's pretty close. We know homes consume more energy after they get solar. Maybe they're getting excited about their EV and we actually want to add some of those solar panels back, but we're going to stick with our 100% offset story. Okay, so let's look at our electrical design. And our electrical design didn't change any because we had these kind of on one string and these modules on another string. So now we have 2 strings instead of 3 strings. That's the only difference. Okay, our inverter is oversized. Now we have a 10 kilowatt inverter with only 8 kilowatts of solar on it. So we could probably take this inverter and edit it down to the 7.6. So that's what I'm going to do, the 7.6. Done. And now our offset or our DC to AC ratio is 106%. Our offset is a little bit over 100%. All right, let's look at our financials. This system price went down to $52,000. So we basically took 20 grand off of the system cost because we just reduced our number of modules. We went from 29 solar panels down to 18 solar panels. All right, let's look at the impact on the summary reports. Okay, so here we are, summary reports. Let's scroll down to net bill savings, $76,000 from smart batteries, $17,000. So we still have, a payback period of less than 7 years, 6.7 years. Now that's assuming a cash deal. So 6.7 years, that is incredible. So by right sizing the system to 100% offset, a little bit over 100% offset, 2 batteries and no backup, we have basically said, yeah, this system is going to act just like a NEM 2 because we're able to take that excess solar energy and store it in a battery. 47% of the energy consumed by the home is in a battery. So let's do one last scenario. Let's say, okay, we pitch this to our customer. They love it. They're like, yeah, 6.7 years, but I don't understand having 2 batteries on my wall without backup capability. I absolutely want to have backup power. Okay, that's easy. So we're going to just, again, duplicate this design. And we'll still call it ESS 100%, but then we'll call it backup. Rename ESS 100%, and I'll just do a backup. Cool. All right. So let's add in the cost of a backup system. That's going to be pretty easy. So if you go to the storage tab, we can see an option for backup. So I'm going to click the box that says backup power, and we can define what the backup reserve is. So the backup reserve, what you set the batteries to always have in the tank in case the system goes, in case the grid goes down, is typically around 20%. I always want 20% battery in reserve, and it's going to impact the available energy for time of use arbitrage or the power hours. So 20% backup reserve. You may want to take that down to 0, but most people always want to have something in the tank for backup. And you can define how much power is required for backup. So you go through the house, you look at the largest loads, and you look at what the required power output is. And let's say we're dealing with a 3.5 ton air conditioner that has a high LRA. So maybe we need 15 kilowatts of power. As you can see, as I move this slider up, it's increasing the number of batteries. All right. I'm going to drop it down to 10. Maybe they're like my home. I have a brand new Lennox air conditioner that is very efficient, and the LRA is only 20 amps on it. So I can back up my system with a single battery. However, I am the minority, and most homes don't have super efficient air conditioners like I do. Okay, so we're going to say still 2 batteries because we want to keep everything the same. I'm going to apply this in the electrical design. And look, we still have 1 inverter, 2 batteries, same exact 7.6 kilowatt inverter. Looks good to me. Let's go ahead and get to the financials. All right, so financials, now we have to add the cost of a backup system. So one thing we may want to add is a backup interface. So let's add a backup interface. Backup interface, there we go. And we can see that this is we can associate a cost to the backup interface, and I'm going to just pick a random number. We're going to call it $1,500. So we added the backup interface. We assigned it to about $1,500. Let's add another item. Okay, we're going to say EBOS, and this is just the amount of work it takes to install a backup panel. And roughly speaking, a backup panel, if you're going to do a full home backup system or a partial home backup system, is about the same cost as a main panel upgrade. Usually, depending on the number of circuits you're moving over, how skilled your electricians are, I see typically around $3,000 to $5,000. That's right around in there. So I'm going to again split the difference and just say $4,000 is what it costs to install a backup panel with a backup interface. So roughly adding $5,500 to the total cost. All right, so now we can generate the summary and reports and look at what the cost of adding a backup system is. Okay, so we scroll down and here we are, $73,000. So we still have a really high lifetime bill savings, roughly the difference of $3,000, even though we spent $5,500 on a backup system. We only lost $3,000 in bill savings. So really we got half of it for free. $14,649 from the battery. So that's kind of reduced because we're reserving 20% of the battery's capacity, right? So that's why we see a reduction of savings specifically from the battery. But now our homeowner has a nice backup system. Our bill offset 100%, 19.5% from battery. Net monthly bill savings is $326. Man, this is a great system. And again, our payback period is 7.5 years. So we could tell our homeowner, all right, it's going to cost you 10 months, maybe a year to pay for a year extra to pay for that backup system, but we can put it in. And of course, you can take any of these reports and send them to the customer. So just from here, you can share the report, share whichever one you want to, and say, here's your 4 options: max fit, PV only, max fit with battery, max fit with, right size, I should say, right sized with battery, and then battery with backup. And the cost of adding backup is very minimal. Just to show you, NEM 3 requires batteries to be successful. And if we're looking at cash deals, we're still looking at 6.5 to 7.5 year payback period, which is incredible. Once again, my name is Cameron Stewart. Thank you for watching my SolarEdge Designer demonstration in NEM 3 and how to be successful. I cannot reiterate enough. Make sure you're installing batteries on every job in California. It's going to be critical to your success. I hope you have a great rest of the day. Call us if you have any questions to our support line. Chat us if you have any questions to our chat line, or you can call your local SolarEdge representative. Thank you and have a great day.